Okay guys, welcome back to the new video. Today we're going to see how you can basically insert a node at a given position. In my previous video you guys have seen how I implemented this insertion after a given previous node. Now this time we will see if there is no node specified, how we can insert a given node at a given position, right? So let's first elucidate what will be the concept. Okay, so let's start. Suppose there are two linked lists. I mean there are two nodes in a linked list, right? This is one, this is two, and I need this number 3 node to be inserted in this position such that the resultant will be like this, right? We have here, let's say 10, here 20, and here 30. So the resultant will be 20, 10, and 30, right? So let's first understand the concept, how we can do this. And if you guys have seen my previous video how we are inserting a node after a given previous node, then this method or this ideology is very easy for you guys to understand. Okay, so let's first cut this out and basically see what's going on. Okay, what we can do is we can keep a counter. Yes, now you guys will be asking, why counter? Like, what is the use of it? If we traverse, if we first declare a pointer, let's say current is equal to, and started with the head position, the initial one, and if we traverse through the linked list with the counter incrementing every time we go to the new node, like C++, and this will be current is equals to current dot next, right? So every time the pointer goes to the next node, the counter increments by 1. Like this, basically what we are doing is we are keeping the index position of every node into the counter. Every new index position is being replaced by the old position that is being stored in the counter variable, because every time the counter variable is changing with the new value, right? So we will be given with a key. I mean, key is that particular index at which you need to basically insert the node. So that key, the condition is if that key becomes equal to the counter at that position, then we will come out of the while loop, come out of traversing the loop, traversing the linked list. Yes, suppose there's a person and I ask that person to basically traverse to the linked list, and he goes 1, then 2, then 3, and as soon as he found the 3 index number and it matches with the key, that is that position at which we need to basically insert the node, he stops traversing and his value or the current pointer's value is basically pointing towards that previous node at that moment. I mean the node which is on the third index, right? So we got the previous node. So by the time when we get the previous node, we can basically use the logic of our previous video, like how to basically add a node with a given previous node. So we will be given as a key, we will traverse through the linked list, we will keep a counter, we will change the counter every time when it goes to the next index, and as soon as that counter becomes equal to the key, we will stop traversing, come out of the loop. The current pointer will point to that particular node which was present at that particular index at which we need to insert the new node. Then we'll be getting our previous node as the current pointer, or we can basically cut this and we can keep it as prev node or whatever it is. We can name this thing as this way also, for your understanding, for your clarification, right? So we got this previous node, then we can do it by same logic in the previous video. Easy yes, tell me guys, isn't it easy? Many of you basically get this complication. Oh my god, this is I only have done it with only the previous node that was given. Now the previous node has not been yet given. How will you do it? How will we do it? Like we are only given the index position. It's just a common sense, it's just a logic. You don't even need to open GFG to see the code. It's all there in your mind. So it's just imagination and ideology, nothing else. Data structures algorithm is all about imagination and ideology. How much you understand the concept, how much you analyze the situation will prove how much you know the DSA. So we're good. We can shift to the code. Let's do that. I've already made these prerequisites, so I don't need to basically write the code again and again. So I guess you understand this portion, and this is just the insertion at the beginning, and this is just printing the list, and this is that driver code portion where we are creating an object of the class and we are calling the functions. Okay, so we just need to create the required function. Okay, so let's create that. Okay, insert at pos, let's say I give it a value of a key and then a parameter did, right? And then we gonna create a new node as usual. Same, nothing is there, nothing new, same as usual. Single linked list playlist is gonna be the easiest one, I guarantee you guys. And this course, this bootcamp that I'm posting, this amount of easy things that I made you understand, the amount of easier way that I'm making you understand, you can get it nowhere. Not in the books, not even in the articles. If you go in the articles, you will see the codes and you will get complicated, you will get complications, you can get complex thinking in your mind. So follow my lectures, follow my concepts. I'm making you understand as easier as that, making you understand full concept in an easier way, because I know, because when I was a beginner, I also had that inferior complexity of understanding data structures. I'm still learning some advanced concepts, but thing is, if you make the things in an easier way, if you understand the things in your real life problems, if you can idealize data structures as your real life problems, or if you can understand data structures in an easier way, try to understand it very efficiently, then you can master it. And mastering it is not a very big tough problem. It's very easy. You just need to understand the concept, and for that I'm trying for you guys so that I can make you understand in a very easier manner, so that you can understand each and every concept and you just don't need to mug up every algorithm. Okay, When we were in kids, when we were in school back in the days, we used to basically mug up all these linked lists and stack queue codes. But nowadays, you see my lectures, if you see this, I guarantee you, if you listen properly, you are never gonna forget any of the portion of the code. Never gonna forget. You don't have to basically mug up. So I can guarantee you that. But yes, you have to basically go on with the lectures. You have to basically practice your codes. That is very essential. And don't skip the video. Don't skip any part of the video. Okay, I request you guys for that. Okay, so I can create a node with the data, right? Then basically what we can do is visualize a counter. And then I can keep this as a new pointer, and I can say prev node not equals to null. This means that the linked list isn't empty. We will traverse. I can keep a counter plus plus, and if I see if counter equal to key, then we come out of the loop, else prev node is equals to prev node dot next. Traverse, we traverse to the next node, right? As soon as we break out of this loop, that previous node will be stored in this pointer, right? We'll have this value over here, so we can use that thing by inserting the node. How we can do that? Yesterday's logic. Yes, easy, isn't it easy? Now let's see, moment of truth. Insert at position. Let's say I'm gonna insert it at 2. So I have to mention it index -1, because if I want to insert it at a 2th position, I mean I'm inserting it on the 20th position, then I have to give the index before that, because that becomes like 10 becomes the previous node, so I have to give the index of the previous node, right? So that is easy. So this will go like 20 becomes the previous node, sorry, because I'm just doing in a insert at the beginning. So 20 becomes the previous node, then 40, then 10. Let's see. Yeah, so clear, I guess. This is done. This was easy. Easiest things, guys, not to worry about anything more. We just did same as the previous video. We just did what extra, we took a counter and we traversed the linked list till the counter becomes equal to the key. When it becomes equal to the key, then we come out of this loop, and we, after coming out of this loop, this previous node consists of that previous node. This previous node counter, I mean previous node pointer, points to that previous node where we want to insert the new node. So after getting the previous node pointer, we use the same logic as before. Like when that previous node pointer was given initially, we just needed to do 2 steps, that is link it with this one, then push it into the linked list. So it is easy, same logic, just to add some more flavors, nothing more. So I guess you guys have understood this, and I hope you guys will practice this code in your home. And if any doubt about this counter portion or traversing anything, please comment down below. Don't hesitate that. And if you are new to the channel, please don't forget to subscribe. And if you already did, then don't forget to basically like and hit the bell icon for latest upcoming videos in data structures. I'm currently making the single linked list bootcamp playlist, so I'll be giving more videos in the upcoming days, like deletion, reverse linked list, and all other categories of problems. I'll be posting those. So till then, bye bye, have a nice day.